There are different types of control systems used in robotics. In open-loop control, the computer sends signals based on the current state without taking into account feedback from the system. This type of system is also called non-servo, or pick-and-place, and is used in about 35% of the robots in the United States. In open-loop control systems, signals are first sent by a computer controller to the system driver. The system driver then converts those signals into an operation for the process or robot to perform. The system driver can be anything from a pneumatic actuator, a hydraulic flow valve, or an electrical controller. In open-loop systems, the program length of time the signal is applied, as well as the integrity of the signal, are critical for ensuring that the new operation is completed. This is because there is no feedback to the computer from the system driver or the robot, and thus no updates to the signal outputs can be made. The term process in this illustration simply means any piece of equipment that accomplishes work. This could be a robotic arm, a motor, or an engine. For the purposes of this module, we'll focus on robots. Once the signal is received, the robot performs the appropriate action. In an open-loop system, the signals that go from the computer to the system driver to the robot are never checked with a feedback loop to ensure that the robot has completed its task. A simple example of an open-loop system is an industrial sprinkler system. In this example, the programmer updates the computer controller, which will turn the sprinkler on at a designated time. When the computer sends the signal, the water valve will turn on. When the valve turns on, water flows to the sprinkler and drives a motor that allows the sprinkler to simultaneously move along the field and water the crop. Some good examples for open-loop control systems are stop-and-go conveyor systems with constant loading, and manufacturing applications with high repeatability and low variation, such as punching holes out of a piece of sheet metal or reorienting workpieces. Material handling and machine tending operations also account for many open-loop design applications. Due to their lack of speed control and lack of flexible work positions, open-loop control is useful for well-defined systems where the relationship between input and the resultant state can be modeled. The positions of the robot can be predetermined and the loading environment does not change. Open-loop control systems are typically low cost due to their simplistic design, high repeatability, and controller simplicity. They should be used where motion is predefined, repeatable, and does not vary. The second type of control system is called closed-loop control or servo control. A servo is a device that uses error-sensing feedback to control the motion of another device. The primary difference in an open versus closed-loop system is the addition of a feedback loop that allows the controller to make adjustments to the robot. In our previous example of a sprinkler, the system was open-loop because the controller received no feedback. But if a moisture sensor is added, it becomes a closed-loop system. The sensor measures the moisture density of the soil and sends that information back to the computer controller. The computer can then make adjustments to the quantity of water coming from the sprinkler. The advantages of closed-loop control systems include flexible program control, ease of changing programmed points, the capacity for complex manufacturing tasks, and multiple program storage and execution capabilities. These flexible capabilities allow the same machine to utilize multiple programs with different operations based on the work being presented, all without a change in machinery. Closed-loop systems require a larger upfront capital investment and highly skilled maintainers, but the payback comes from a much larger range of capabilities. Closed-loop controllers are used in machining, welding, coating and sealer application, material handling, machine tending, arc and water jet cutting, inspection, and assembly operations.